Hi guys, Astrochemistry here. I hope you're doing all fine. This will just be a short update video and introduction video for some projects that I have been planning, and also I wanted to report in on some progress that we've made in the last months regarding some basic requirements for some future projects that we want to do in the near future. So let's get started and let's dive right in. So as you might have noticed, we have been gone from YouTube for a little while, and this is because of a severe illness that I've had. So I wasn't able to do anything, and of course that includes YouTube, but thus far I'm on the road of recovery, and I hope that I can produce some nice high quality content and show some interesting projects in the near future. So in the last months, I have been building a reliable and powerful high voltage power supply, and this will enable us to do some really nice experiments in chemistry and physics. To name just a few, some basic plasma chemistry, plasma spectroscopy, investigating the Birkeland-Eyde process, the synthesis of ozone, and the big project would be X-rays and crystal structure analysis. So first, let's talk about the high voltage power supply. I have taken this short clip. So this shows the arc discharge between the two electrodes. This power supply outputs AC at about 20 kilohertz and about 30 kilovolts. And it is cool that this outputs AC, because in this way we can simply use a voltage multiplier to step up the voltage to any level that is required. And it is really nice that this is working so nice, because for years we have been lacking a proper high voltage power supply, and that limited some of the experiments that we could do. So first of all, let's talk about the Birkeland-Eyde process. If you don't know, this belongs into the group of the oldest methods for synthetic nitrogen fixation. And this uses the electric arc spread out into a thin plasma disk as the reaction medium for facilitating the reaction between nitrogen and oxygen. Because as we all know, air consists mostly of nitrogen and oxygen. So if you find a way to directly oxidize nitrogen in the presence of air, you then have nitrogen oxides which dissolve in water to yield nitric acid. And this is a really neat method, although energy intensive, and it works by having a regular arc between two electrodes, just like you saw in that little video earlier, and then applying a magnetic field perpendicular to the axis of the electrodes, and due to the Lorentz force, this causes the arc to spread out into this kind of plasma disk, which of course greatly increases the surface area and also reduces the wear on the electrodes. So thus far we have been experimenting with very strong neodymium magnets, but we have been unable to afford a proper plasma disk so we can generate a stable arc, but thus far we have failed to properly form this plasma disk. So this will be a project that we will work on, and eventually when we'll get it, then we'll make a video about it. As I said, it is a neat process because really all you need is electricity and regular air, and you can produce yourself nitric acid. Although this would not be the first. This is really not the best method because it is so energy intensive, so the electricity bill will be high as long as you don't have other sources of free power like solar cells. Now, another interesting thing that we can now do is to do some plasma chemistry and plasma spectroscopy. And of course, this electric arc is ridiculously hot and it will ionize and atomize almost anything. So we can easily determine atomic emission spectra and thus determine elements that are present in a sample, for example. And basically all you have to do is to introduce a sample into the plasma and then use a spectroscope to view the flame. And we already own a spectroscope. You can see some nice pictures right here. These are actually pictures of the sun. And if you look closely, you can see these dark Fraunhofer lines. And these are due to the elements that are absorbing part of the sunlight in the sun itself. So this is like a nice project that can be done now because we have everything. We have the high voltage power supply and we also have the spectroscope. So that's really cool. And yeah, you might know you can also do some spectroscopy by just taking a probe and sticking it into a Bunsen burner, and that works as well. But the advantage with the plasma and the electric arc is that it is so hot that the colors will be much brighter as you manage to ionize a lot more atoms in there because of the higher temperatures. Another interesting class of reactions that is now accessible is ozone, since it is ridiculously simple to synthesize with a high voltage power supply, as you just have to lead air or oxygen through a corona discharge, and this will yield some ozone in the gas. And as we have oxygen in a bottle in the lab, we can easily build an ozone generator, and I will show you a neat way how to do this by simply modifying a Liebig condenser. And really, ozone is interesting because it is the strongest, easily accessible oxidizing agent, and only fluorine and some really rather exotic compounds of xenon are stronger oxidizing agents. Now, the most important or interesting reaction, I shall say, for ozone is the direct reaction with ammonia, as this will directly yield ammonium nitrate. So our next video will probably be about the reaction of ozone with ammonia, and in theory this should directly yield ammonium nitrate in the gas phase. This is of course an interesting reaction for the amateur chemist, as this is, I guess, the simplest way you can make ammonium nitrate, since you only need air, the power supply, and ammonia. So that's going to be pretty interesting. And of course, if we can make ozone, we can also demonstrate a lot of atmospheric chemistry that is going on. You know, we can show you what happens with ozone and nitrogen oxides, or fluorinated or chlorinated carbohydrates, or carbon compounds. So, and the biggest and long-term project is the topic of X-rays, so their production and how we can use them. And I would really like to be able to perform crystal structure analysis at some point. So thanks to our patrons, I was able to order an old Soviet X-ray tube that you can see in this picture right here off of eBay, and this is currently in the mail and should arrive in the next weeks. This will be very interesting as this unit comes from an actual X-ray diffractometer, so this will hopefully be of great use. So thanks a lot to the patrons that have made this possible, and thank you very much for supporting us, even though we haven't been very active lately. So of course, also if you're not a Patreon yet, but would like to help us out, then feel free to check out the link in the description. And also if you want to support us continuously, you can do so, or just for one time. So thanks a lot. So why is an X-ray diffractometer interesting? It would allow us to do some experiments with crystals and crystal structure, as X-ray has a sufficiently small wavelength that it will actually interact with atoms itself, since they are on the same length scale. And it is really cool because it allows you to determine structures and how things work on the atomic level. But this is a very long-term goal, as it is both expensive and very tough to build and to perform these experiments safely. So currently, as I said, the X-ray tube is in the mail. The high voltage power supply is working, but it is outputting AC, so we will need to purchase some high voltage diodes and high voltage capacitors to step up the voltage to around 110 kilovolts. And we'll also need to think about shielding. So thus far I have planned to shield the X-ray apparatus with water, since it is cheap and in a sufficient width it will reduce the amount of X-rays significantly. However, I will also go and look around if I can find some scrap metal like iron or aluminum that will also help to build a proper shielding for the X-ray unit. But as I said, this is a very long-term project, and the speed at which it progresses will be greatly determined by the finances. So of course this is very expensive, so it will take some time to get the money together to purchase and to build all of this. But even without a diffractometer, we can still perform a lot of highly interesting X-ray experiments that I'm really looking forward to. So hopefully you enjoyed this short little update and you're excited as I am for these upcoming projects. So as I said, as I planned until now, the Ozone video should be the next, although I cannot guarantee that these reactions with ammonia will work out immediately. So at least the video about the ozone production should be out next week. And then depending on how the experiments go, I will either include the ammonium nitrate synthesis directly into that or do a separate video. So until then, and see you there.